Direct variation is a specific relationship in which there is a constant ratio between all ordered pairs. So direct variation equations are written as y equals kx, and sometimes you'll have to solve for k, and it would be k equals y over x. The big thing that you need to remember about variation is that k is what we call the constant of variation, and so that is the relationship that they have between the x and the y. So if we are trying to solve for k or find out what k is, and we're given ordered pairs like in the problems below, what we should do is we should use k equals y over x. And so what we do is we take each of these points, they each have an x and they each have a y. Remember, the first one's x, second one's y, and I'm going to figure out what the k is. The k should be the same all the way across. So I'm going to have k equals 4 over 1, which is 4. If I do 8 over 2, that's going to give me 4. If I do 12 over 3, that's going to give me 4. And if I do 16 over 4, that's also going to give me 4. So that means that my k for this direct variation would be 4. And my equation for that would just be y equals 4x, because my direct variation equation is y equals kx. So I just replace that k with a 4 and leave the x and the y. Alright, I can do the same thing for number 2. So on number 2, I need to find out what k is. So I'm going to do y, which is 3, over negative 6. Well, 3 over negative 6 would become negative 1/2. So I can do that for all the rest of them. Do 2 over negative 4. 2 over negative 4 is going to be a negative, and then 1 over 2. 0, 0. 0, 0 is special because 0, 0 always has to show up in order for us to have direct variation. So make yourself a note that 0, 0 is always included in direct variation. So even though when I do 0 over 0, it doesn't give me negative 1/2, it's still part of my direct variation, and so I can just move on to the next one, which would just be negative 1 over 2, which would be negative 1/2. So my k would be negative 1/2, and when I went to do my equation, y equals kx, I would have y equals negative 1/2 x. The next two examples are written in a different form, however it still is the same thing. So remember that when we have a table with x values and y values, that means that across the row is going to be my point. So this point would be negative 12, negative 8. This point, negative 6, negative 4. This point, 0, 0, and then 3, 2. So I would still find the k by doing y, negative 8, over negative 12. Well, negative divided by a negative would be a positive. And 8 over 12 would reduce to 4 over 6, which would keep reducing to 2 over 3. So 2 over 3 would be my k. I could do that for negative 4 over 6, which would turn out to be 2 over 3. 0, 0 is always included, so I can skip that one, and then 2 divided by 3 would just be 2/3. So my k would be 2 over 3, and my y would be 2/3 x. You try number 4 on your own and see what you get. In the next section, we've got identifying equations. And so if we are identifying equations and trying to decide if they're direct variation, they should be written in the form y equals kx. And if they are written in that form, then I need to determine what the constant of variation is. Remember that we said constant of variation was just going to be our k. So on number 5, we've got y equals 3x. So that is written in the form y equals kx. And so since it is, I need to know what k is. And in this case, k would just be 3. On number 6, I've got y equals negative 4 over 5x. And so this is written in the y equals kx form. So yes, and k would be equal to negative 4 over 5. In number 7, I have y equals 2. That is not written as y equals kx because it is missing an x. Number 8 is a little tricky because it's written 2y equals 5x. But remember in our direct variation equation, it's y equals, so y is by itself. So try to do that first. Divide both sides by 2 so that you can get y to be by itself, and you have y equals 5 over 2x. So that is written as a direct variation, and k would be equal to 5 over 2. On number 9, I've got y equals x minus 4. This one is not written in y equals kx form because it has that negative 4 at the end. Now I said that it includes negative 4 as the y-intercept. Remember when we talked about y equals mx plus b? And we talked about how that was going to be a straight line. Y equals kx, which is our direct variation, is very similar to y equals mx plus b. The only difference is this one's missing a b. Well, remember that b represented our y-intercept. And we also said that the point 0, 0 had to be included. So our y-intercept would technically be plus 0. So this one having the negative 4 lets me know that it doesn't cross the point 0, 0. It crosses the y-axis at negative 4. So this one has to be a no because it doesn't have a plus 0 or it includes a plus b. Number 10, I've got y equals negative x, and so this one would be a yes because it is written in that y equals kx form. My k in this one would be equal to negative 1. You try 11, 12, and 13. When we are identifying graphs of direct variation, remember that we have to include 0, 0. And so we sort of touched on that a second ago when we talked about that the y-intercept had to be 0. Remember, it's written y equals kx, which is similar to y equals mx plus b, except it's missing a b. So when I look at my graphs here, I need to look for graphs that cross the y-axis at 0, 0. So this one would be an example of a direct variation because it crosses a straight line that crosses through 0, 0. To find out what my k is, remember we said k was similar to y equals mx plus b. K and m would be the same thing. So my k would technically represent my slope. So I would find out how far I go up or down to get from the point on the left to the point on the right. We did this back at the beginning of the semester. So to get from here to here, I would go up 1, 2, 3. So I'd have a rise of 3. And I would have a run of 1, 2. So my slope in this one would be 3 over 2, which means my k would also be 3 over 2. If I were writing the equation for this line, it would be y equals 3 over 2 x. Number 15 would not be an example of a direct variation, mostly because it crosses the y-axis at positive 4. You try 16 and 17. Finding missing values. And so sometimes we will be given 2 points or 2 situations. And in those 2 points we have an x and a y. And so sometimes we'll be given 1 point that has both parts and 1 point that's missing part of it. And we'll be told that it's a direct variation. Remember with direct variation it's y equals kx. And we can also say that k equals y over x. And so what we're going to do is we're going to use both of these equations in order to find that missing value. The first thing that we're going to do is find our k. Our k is going to use our x and our y together. And so I need to use the point that has x and y together in order to do that. So I'm going to do negative 4 over 2. And negative 4 over 2 just turns out to be negative 2. So that gives me my k. Now I'm going to go to y equals kx. And I'm going to plug in the information that I know, but this time, instead of using this point, I'm going to use this point. So I know that my y is just y because that's the part I'm looking for. I know that my k is negative 2 because that's what I just found. And I know that my x is negative 6. So my y turns out to be negative 2 times negative 6, which would be a positive 12. Again, I'm going to use, on this one, I've got x and y and x and 24. So what I'm going to do is try to find out what k is first so that I can figure out what that missing value is. So if I'm finding out k, I'm going to do y, which is 16, over x, which is 4. So 16 divided by 4 gives me 4. Now I'm going to use y equals kx, which is my direct variation equation, and I'm going to plug in what I know from this set of parentheses. So I have 24 equals 4 times x. Well, 4 times x, that's going to divide out so I can get x by itself. And when I do 24 divided by 4, I find out that x is equal to 6. You try 20 and 21. 20 is like 18, and 21 is like 19. (22) through 25, even though they're written differently, are no different than what you did in 18 through 21. So, in 22 it says, if y equals negative 18 when x equals 3, find x when y equals 30. So what I can do is take the information that they give me and write it like I had in my examples in 18 through 21. So, I could take y equals negative 18 and x equals 3 and turn it into 3, negative 18. And over here, I don't know what x is, but I do know that y is 30. So now I have a problem that is so similar to 18 and 19. So first I need to find my k, which in this case would be negative 18 over 3 because I do y over x. When I do that, that gives me negative 6. Then I'm going to do y equals kx and plug in what I know. I know that y is 30. I know that k is negative 6. I don't know x. So to get x, I'm going to divide both sides by negative 6, and I find out that x is equal to negative 5. You try 23, 24, and 25. Inverse variation. So with direct variation, our equations were y equals kx and y equals k over x. Inverse variation is going to be a specific relationship in which there is a constant ratio between the ordered pairs, and our inverse variation equations are going to be y equals k over x and k equals xy. So if I'm finding the constant of variation, which is my k, I need to use k equals xy since it's an inverse. So all I have to do for this is I say k equals 1 times 20. Remember, the first number is my x, second number is my y. So 1 times 20 gives me 20. Now I have to check my other points and make sure that they work out. So 2 times 10 is 20, that works. 4 times 5 is 20, so that works. So if k is 20, and I know that this is an inverse, I'm going to say that my equation would be y equals 20 over x. You try number 2. On number 3, I have an xy table. I know that each of the rows is going to represent 1 point. And so, to find out my k, I just choose one of the rows to use for x and y. I'm going to go with negative 1 times 12. So I know negative 1 is my x, 12 is my y, and so since I use k equals xy, I just do negative 1 times 12. Negative 1 times 12 gives me negative 12. So since I know my k, now I can use y equals negative 12 over x and get my inverse variation equation. You try number 4. When we're graphing inverse variation, we have to keep in mind our relationship when we have inverses. Remember that y was equal to k over x and that k was equal to xy. That's going to be important anytime that you're using inverse variation. And so knowing that, in my problem it tells me that the constant of inverse variation is 16. all that means is that k equals 16. And so if k equals 16, I can replace that k with a 16, and I know that I'm going to have some x values and some y values that will multiply to give me 16. Now, if I need to graph that, I need to do an xy table. You remember that's how I graph any points on the graph. So in order for me to have two things that will multiply to give me 16, I have to think about anything that I could multiply that would give me that. So like 1 and 16 would work, and 2 and 8. And 3 doesn't come out to give me an even number, and since I'm graphing it, let's leave that one out. 4 would work though. 4 times 4 would give me 16. 5 would give me a decimal. 5 times a decimal would give me 16. 6 would also give me a decimal, and so would 7. So I could use 8 and 2. Alright, so let's put those points on the graph. So if I went to the point 116, keep in mind that on your x-axis, each one of these lines represents 2. So that would be 2, 4, 6, 8. And so if I had 116, I would go halfway in between the 0 and the first line, and I would go up to 16, and I'd have a point right there. For 2, 8, I would go to the first line, and I would go up to 8 and have a point. 4, 4 would have a point there, and 8, 2 would have a point there. I could keep going with my list, but that gives me kind of an idea about what my graph is doing. Now notice that your graph is never crossing the y-axis. Remember that on your y-axis, every one of these points is 0 something for your y. And so the reason that that doesn't work, that you never cross your y-axis, is because nothing times 0 would give me 16. Same thing goes for the reason why you never cross your x-axis. Every point that's on your x-axis is a number and then 0. So like this point would be 4, 0. Well, there would be no number that I can multiply by 0 that would give me 16, so that's why I never cross on the x-axis as well. However, I could have negatives that I could multiply to get positive 16. Remember, in order to multiply to get a positive, I would have to have two negative numbers. So it's possible I could have negative 1, negative 16. Even though those are negative, they still multiply together to give me positive 16, so they work. Negative 2 and negative 8 would also work. Negative 4 and negative 4, and negative 8 and negative 2. So I have this part of the graph, but I also have a part of the graph over here that looks very similar. So I'm going to skip negative 1, negative 16, because remember we kind of had to do some crazy work there. But I could put negative 2, negative 8 on my graph, and negative 4, negative 4, and negative 8, negative 2. So that kind of gives me an idea that my graph looks like this. So keep in mind that with an inverse variation graph, you're going to have kind of the reflection on your graph. So two parts. You try 5 and 6. So finding missing values for inverse variation. Remember that with inverse variation, when you are trying to find missing values with inverse variation, you've got to keep in mind what your y is equal to. So your y is equal to k over x. And if you were trying to figure out what k is, you would use k equals xy. So this is similar to how we did the direct variation problems that were missing values a little bit ago. First, we have to start with the set of parentheses that include both x and y. And so we're going to use k equals xy to find out what our k would be equal to. So we have k equals 12 times 14. Well, 12 times 14 gives me 168. So now I'm going to use y equals k over x and plug in the information that I know. I don't know what y is, but I do know that k is 168 and that x is negative 24. So when I do 168 over negative 24, I get that my y would be equal to 7, negative 7. You try 8 and 9. For number 10, I've got x and negative 7 and 21 and negative 3. So again, I'm going to find k first. To find k, I'm going to say 21 times negative 3. Well, 21 times negative 3 would give me negative 63. And then if I wanted to find out what x is, in my first set of parentheses, I would use y equals k over x and plug in what I know. So I know that y is negative 7, I know that k is negative 63, and I don't know what x is. So that's going to give me negative 7x equals negative 63. Divide both sides by negative 7, and I get that x is equal to positive 9. On 11, 12, 13, and 14 at the bottom, these questions are exactly like 7 through 10 were. The only difference is I just need to rewrite them to where there are two sets of parentheses. So in 11 it says if y equals 9 when x equals negative 6, find x when y equals 3. So what I have here is two sets of parentheses, one where I have negative 6, 9, and one where I have x, 3. So I went with negative 6, 9 because x was negative 6 and y was 9, and I need to always use x and then y. So first I'm going to find k by saying negative 6 times 9, which gives me negative 54. Then I need to use y equals k over x and plug in what I know. So I know that y is 3, I know that k is negative 54, but I don't know what x is. To get x out of the bottom, I always have to multiply by the number on the bottom to get rid of a fraction. So I'm going to have 3x equals negative 54. Now I'm going to divide both sides by 3, and when I do that, I find out that my x would be 18, negative 18. You try 12, 13, and 14.